to update you, alright, we have already solved the answer, but perhaps the lecturer also want to evaluate on the deflection if it's needed. Alright, so the question asks us to find what will be the bending stress and the shear stress distributed on the beam section, and that's all. So we have found the shear stresses, the bending stresses at this one. Alright, this is for the face, this is for the core, although the values are a bit weird. Alright, but anyway, so as for the what's that called, shear stresses, we have found for the face, since the question didn't indicate much of whether is it the face of the module, or whether is it the face or the core, sorry, or both of them. So in this case, he just simply calculate for the face and that's it. Okay, you may want to calculate for the core as well as the face plus the core. You can do it yourself. Alright, and this is in the previous video 11.5. In case you don't know where the hell is 11.5, you can search in the playlist. So these 4 videos are the previous parts of this current video. Alright, if you keen, you can watch from there. Let's continue. So to find the deflection, this is the deflection, you need to find W. So what is W? W is the total forces acting on the beam. Alright, it's not at the middle part already, it's talking about the total beam that is taking in the stress. So it's 1500 Newton. Okay, so W is 1500 Newton. Maybe I should write properly. The length L, alright, is just 200 millimeter, which we have just keep on saying. Alright, this is the overall thing already. So from here we can infer that for deflection calculation, you need to talk about the full structure, alright, the full force and the full length itself. Okay, unless predetermined, because you may look at the different L, you may talk about half of the length. If it's half of the length, then the weight will be different, or the W will be different. So it depends on what type of deflection are they talking about. Alright, but I don't know. Anyway, let's just follow the rule. Alright, W and L is this values I've explained to you. D is the flexural rigidity, giving us the problems always. This one, this is the D that we have derived. So if you want to know more, you can head back to the shear stress, the bending stress video 11.3, you can watch it. So the D, we have known the values already, alright, which is that value. And then G, now it's only calculate the G. Alright, and in fact A also. Okay, A is just this thing, BD squared over C. If I'm not wrong, you should memorize everything also. I didn't. Yeah, you need to memorize this thing. Okay, you need to memorize this one. Oh, sorry, you need to memorize everything. Yeah, this is from the lecturer. Yeah, if I never copy wrongly. Yeah, you need to memorize everything. Okay, so yeah. Anyway, so this A is equals to the BD squared over C. So B and D, I think you know what the hell is already. So these are all the BD, and then the C is this one. C is this one. So in other words, the length of the core, things like that. So it's just application already. So when you memorize, practice more. Or I think you need to practice a lot in order to sink the equation into your mind. While the G itself, let's take a look. So this is the equation of the shear modulus of the core. Take note, it's shear modulus of the core. So the Young modulus of the core is 160 mGPa, right? So we just use it as times 10 to the power of 3 MPa. Alright, divided by 1 plus. Alright, the polyuterine Poisson ratio is not given, and this I think is the only thing that is having the problem. But nonetheless, we get the answer as 30 MPa. So I don't know what is exactly the Poisson ratio. If I were to solve for it, let's see what it goes. You know what? If I were to calculate for this, something is wrong. Okay, the answer is weird. Poisson ratio is 2665. I don't know what the hell is going on. Okay, if I don't use 160 times 10 to the power of cube, let's see. If I use 160 divided by 60, what do I have? Okay, so it's 1.67, something near there. So I think this is not the. So when you calculate for your Young modulus, you can straight away use in gigapascal. But no leh. He's in terms of megapascal . Yeah, his answer is in terms of 30 megapascal. So the Poisson ratio can't be 2665 what, right? Something is wrong again. See, everything is wrong. I don't know. Anyway, you get the meaning of it. So you need to calculate. So don't be distracted by what I'm doing right now. Your purpose is to calculate for your G. So you use the Young modulus of your core with your Poisson ratio of your core, and that's it. Finish. Alright. Don't go into all these things. There is alternative way of solving this thing, because this is in terms of the amount of materials. Alright, but there is another way of using your shear of finding your shear modulus, and this way is coming from sorry. In fact, I don't know where is it. I think it's at this part 7.7, the maximum deflection of sandwich panel beam in bending. Alright, but I can't find the G explanation, but I just want to highlight to you that if it's E1 for example, then it's V Poisson ratio 2:1. If it's E2, then it's Poisson ratio 1:2. Alright, things like that. So I don't know where did I actually explain that somewhere, I forgot, but something for you to take note of. Nonetheless, there is also another shear modulus that is one I want you to know, is from this video 7.7. alright, at about 2.25. okay, that talks about the axial stiffness matrix, if you remember. Alright, this is the one shear modulus of the laminate. If your core is a laminate, then you can use this type of shear modulus. Alright, if your core is a laminate. So our core itself, but normally your face is a laminate, your core is not a laminate. So sorry. So I think this is not applicable over here. But at least you should also take note, if let's say your core next time if you were to work or whatever, if next time your core is a laminate, then you have to use a laminate. In our case right now, I don't think our core is any form of a laminate. So yeah, so the G itself is giving me a problem again. So nonetheless, when you apply everything, alright, since we have known our A, our W, L, D, everything, alright, I'll just give you the answer. Alright, so the G is actually 30 megapascal, okay, while the deflection is 3 mm. So this is 3 mm. So let's see whether if I were to put in everything, is it correct or not. So you get 0.29. This whole thing, if you calculate, is 0.29. This is 2.7. This is 2.7. Alright, you'll get about 2.99, which is equivalent to 3 millimeter. Okay, so the deflection is correct. Alright, take note of your D is actually this value 854 times 10 to the power of 6. Okay, so you will eventually find that your deflection is 3 mm. Okay, your A itself is equals to let me see, 925, alright, millimeter square. Okay, so let's see whether is the A also correct or not. Let's see. So is B times D square is 18 millimeter divided by C. Alright, you will have a 925.7. Alright, so the only problem that is coming out over here right now is the shear modulus. Okay, the shear modulus is giving me a problem already. Alright, but nonetheless, our purpose, don't forget, is to find the deflection using this formula. Everything is good. WL, I think you know the meaning already. So only the G is giving me a problem, where the Poisson ratio, I don't know what the hell. Okay, so that's the only problem is the Poisson ratio now, and I think the rest should be fine. And at the overall scale, as a summary, I just want to say that your fractional rigidity is always the problem, so be careful, and especially the megapascal. Alright, why will he multiply megapascal with millimeter? Alright, where megapascal is in terms of Newton per meter square. Alright, why don't he convert it? These are the things that I just want to highlight over here as an important stuff. So if there's any update, I'll update individually in other videos, or in the previous videos, I would say. And this ends a hectic thing of this whole video on this stuff, on the sandwich panel. Okay, so in the next video, I'll just briefly tell you, just create this video so that you can take a screenshot of all these tutorial questions in case that you may need it. Okay, so see you in the next video. Bye bye.